Okay, so on your instruction sheet, I asked you to try this roller coaster and then to watch this to see how to do it before you work on the back ones. Whoops, my sheet doesn't have a back one, but your sheet does. Okay, so the standard loop. So it says, how fast is the roller coaster traveling at the bottom of the hill? So we have the height of the hill, we have the speed at the top, we want the speed at the bottom. That's a change in energy. And so for change in energy, we're going to use 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared is equal to 1/2 mv final squared plus mgh final plus 1/2 kx final squared plus E lost. And all of these roller coasters, they assume there's no E lost and there is no spring. Okay, so at the top of the hill, it has both a height and a speed. At the bottom of the hill, it has a speed but no height. All the terms have an m in it, so they're going to cancel. And we're looking for VF. So we have 1/2 mv, I'm just going to rewrite it so it's clearer for you, mgh initial equals 1/2 mv final squared. So the m's cancel. And then to get the VF alone, multiply everything by 2. So VF squared will equal VI squared plus 2GHI. So 10 meters per second squared, and the 2GHI came because I multiplied everything by 2, plus 2 times 9.81 meters per second squared times 80 meters. So 100.62 times 80 plus 100, and then take the square root. You should get 40, so VF should be 40.861 meters per second. It's really 0.7, etc. That's number 1. Okay, the speed at the bottom. Now look at number 2. It says, how fast is the roller coaster traveling when it enters the loop? Well, it hasn't changed its height. It's still at the bottom. So this is also the answer to number 2. Number 3, what is the centripetal acceleration applied by the track at the bottom of the loop? Centripetal acceleration, AC is equal to V squared over R. So that 40.861, or all the digits we have in our calculator, squared over, and the radius is 20 meters. Okay, so square your 40, divide by 20, and you should get 83. So AC is equal to 83.48 meters per second squared. Okay? Number 4, how many G's does the rider feel at the bottom of the loop? Okay, so at the bottom of the loop, the number of G's felt is equal to, remember from today, AC over G, and at the bottom it's plus 1. So number of G's felt is equal to that 83.48 meters per second squared divided by 9.81 meters per second squared plus 1. And when you do this, you get the number of G's felt, 2 equals, so divided by 9.81, and then add 1. So you get 8, whoops, sorry, I forgot to add 1 after I said it, 9.51 G's. Okay, number 5 says, how fast is the roller coaster traveling at the top of the loop? At the top of the loop, it's a change in height. And if it's a change in height, then use energy again. So 1/2 mv initial squared plus mgh initial 1/2 kx initial squared is equal to 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. So no E lost, no spring. You need to decide where you want to call initial. If this was a test or something, you should probably pick the first spot as the initial because you know it's right. In this one, you might want to pick down here because you know it's right because the answers were there and it's easier. But if we pick the first spot, the m's are still going to cancel. And we're looking for VF again. So it's going to be 1/2 VI squared plus GHI, and you want to bring the other term over, minus GHF will equal 1/2 VF squared. Multiply everything by 2. So VI squared plus 2GHI minus 2GHF. VF squared equals, that was 10 meters per second, and we're squaring it. It was 2 times 9.81 meters per second squared times 80 meters, and minus 2 times 9.81 meters per second squared, and the height at the top of the loop would be 40 meters, twice the radius. Remember, you need to take the square root. So again, 100 plus 19.62 times, and that would be 40. And then take the square root, and I believe you get 29.7455, etc. So 29.7456, really, meters per second, the speed at the top of the loop. Number 6 says, what is the centripetal acceleration at the top of the loop? So AC is equal to V squared over R. So this 29.7456 meters per second squared, and the R is 20 meters. So when you do this, squared divided by 20, you get 44.24 meters per second squared. Okay, number 7 says, how many G's does the rider feel here? So number 7, at the top, number of G's felt is equal to AC over G minus 1. So 44.24 meters per second squared divided by 9.81 meters per second squared, take away 1. So you get 4.51 minus 1, so the number of G's felt is 3.51 G's. Okay? And then the last one, running out of room, wants to know how fast is the roller coaster car going over here. So again, it's going to be energy. So again, you would do, so what is this? Number 8, 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared equals 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. So still no E lost, still no spring. If we use the first term again, all these stay. So it'll be 1/2 V initial squared plus GHI minus GHF equals 1/2 VF squared. So VF squared will equal VI squared plus 2GHI minus 2GHF. So 10 meters per second squared minus 2 times 9.81 meters per second squared times 80 meters, whoops, that's a plus, sorry, minus 2 times 9.81 meters per second squared, and this is 35 meters. Remember, that's going to be VF squared, take the square root, and according to the paper, you should get something like 31.35 meters per second. Okay, so this is how you do your roller coaster stuff. I just want you to notice the number of G's felt here is 9.5 G's. And remember we said that what the danger limits were. Okay, so this is why a regular standard loop is not good. It gives you too many G's. And it's why then we switch to the irregular loop. Okay, that has the different radius as you go around. So I now want you to do the other two on the back. Okay.